My name is Maulik Sompura and I am Director of Product Management at OCZ Storage Solutions. Today I'm going to talk about latency and quality of service aspects in SSDs and how our first NVMe based PCIe drive, which is Z Drive 6000, addresses them. Latency is defined as the delay from the input into the system to the desired outcome, or simply in a system one component waiting for another component to complete a task. Now, SSDs, when they first came in, it was all about sequential performance, highest bandwidth to the fullest potential of the interface, SATA 2, SATA 3, PCIe Gen 1, Gen 2. Then importance came on to the highest sustained IOPS, which is an important metric to have. And then the focus was on low average latencies. While low average latency is very important in different applications, there are applications where you can have low average latencies, but you cannot have inconsistent latency where you have these spikes where the host has to wait for the data and the data does not arrive for a certain time. Now, average latency compared to hard disk drives from SSDs are much better. However, these spikes or the wait times are important for certain applications to avoid them. Now, why is it important? The importance comes from the applications. For example, virtualized environment, like some virtual machines will be starved because there are other virtual machines being serviced. Or online transactional processing, where someone is trying to buy something from an online e-tailer and the site doesn't load for certain seconds. This is huge losses to the company. Now, other examples like HPC or high performance computing and transactional financial transactions, stocks, banking, they want the highest performance with lowest latencies. So the quality of service aspect, how do you measure that? It is the consistency of the ability of SSD to serve the IOs under different workload conditions. Now, it is measured into a guarantee of percentage. So 4 nines will be 99.99%, which means that the SSD has to serve the IOs within a specified latency for 99.99%. Some customers may ask for 5 or 7 nines. Now, the obvious question is that hard disks have these moving spindles and you have these head-seeking latency. Why is there a latency in SSDs which doesn't have any moving parts? So SSDs, the main storage element in SSDs today is the NAND, and NAND has certain requirements for read and write, and that depends on the technology node of the NAND and the type of the NAND that SSD is using. Is it SLC, MLC, eMLC, or TLC? Depending on that, your T-read, which is TR, which is a page read time, your page program time, which is a T-prog, or block erase time, which is T-burst, will be different. And as you go lower in lithography and higher the bit stored per cell, you will have longer times. So those will affect that. All of these affect the NAND's ability to serve the I/O from SSD perspective. You have a limited number of channels that you are addressing the NANDs in parallel between the controller and the NAND. There are activities like NAND blocks have to wear level properly in order to meet the endurance requirements. So there is wear leveling, there is bad block management going on. So all these other background activities increase the latency a lot, and it affects the performance and the endurance as well. OCZ's Z Drive 6000 is based on NVMe interface, and NVMe, as you may know, already cuts down 50% of latency compared to SAS or SATA AHCI protocol. So Z Drive 6000 takes full advantage of NVMe, as well as the firmware was developed from scratch, keeping in mind the lowest latencies for enterprise customers. As you can see in this table, we have very impressive read latency of 80 microseconds and write latency of 25 microseconds for 4K random workload. And if you see the quality of service, again for 4K workload, we are multi-fold. We have multi-fold improvement compared to the competition when we measured the same under the same conditions. In conclusion, along with highest bandwidth and very high I/O operations, Z-Drive 6000 wins in the most critical parameters that are important to the enterprise customers: latency and QoS. Thank you.